Day 14 of 75. Today I'm going to show you a string solution that passes 39 out of 41 test cases and then dies a horrible death on the 42nd. Watch this anagram checker. For every character in string S, loop through string T to find a match, then mark it used. Clean, readable, obviously correct. It sails through the small tests. Then LeetCode hands it a 10,000 character string and it times out. Why? Because that nested loop is secretly n squared. Today we fix it, and we steal the pattern that fixes almost every string problem you'll see in an interview. Let's diagnose the bottleneck first, because naming it is half the battle. Your outer loop runs n times. Your inner loop runs up to n times for each one. That's n times n, 100 million operations on a 10,000 character input. The interviewer doesn't even need to say optimize. They just feed you a bigger input and let physics do the talking. The fix is a mental shift. Stop comparing characters one by one and start comparing counts. Two strings are anagrams, if and only if they contain the same characters the same number of times. That's not a search problem. That's a counting problem. Enter Python's counter. From collections, import counter, and then valid anagram. LeetCode 242 collapses to one line. Return counters equals counter T. Counter builds a frequency map in a single n pass. Each character maps to how many times it appears. Comparing two counters is just comparing two dictionaries. Total cost? n. Linear, done. You can even write counters minus counter T equals empty dict. Counter subtraction drops any count that hits 0 or below. Compare that to the sorting approach. Sorted equals sorted T, which works but costs you n log n. In an interview, lead with the counter. It's faster and it signals you think in hash maps. Now here's the payoff. That same counting instinct scales to harder problems. Group anagrams, LeetCode 49. Bucket words that are rearrangements of each other. The naive key is the sorted string. Eat and T both become a. That works, but sorting each word is k log k. The sharper key is a frequency tuple. Count the 26 letters, turn that count into a tuple, and use it as a dictionary key. Why a tuple? Because tuples are hashable and lists are not. That's the language feature that makes this idiomatic Python. Building the key is OK, not k log k. Use a default dict of list, and you group everything in one pass. Different flavor, same family. Longest substring without repeating characters, LeetCode 3. This is a scene set plus a sliding window. 2 pointers, left and right. Expand right, adding each character to a set. The moment a duplicate enters, shrink from the left, and here's the bug that bites everyone. You must remove s at left from the set as you advance left, or your window lies about what it contains. Test it on ABBA. If you forget the removal, the second looks fresh when it isn't, and your answer is wrong. Add the remove, track the max window length each step, and you've got clean n. And the third hash flavor, twosome, LeetCode 1. Not a frequency map, not a scene set, but a value to index dictionary. As you scan, for each number ask, have I already seen target minus this number? If yes, return both indices. One pass, n, and the dict remembers where each value lived. Watch the edge case that breaks lazy solutions. Input 3,3, target 6. If you pre-build the whole dict first, both 3's map to the same key and you lose an index. Build the dict as you go and check before you insert. The lookup happens against earlier elements only. So here's your reusable heuristic. The decision tree to internalize. Given any new string problem, ask 3 questions. 1. Am I counting occurrences? Reach for counter or a frequency tuple. 2. Am I deduplicating or tracking what I've seen in a window? Reach for a set with 2 pointers. 3. Am I mapping a value back to its position? Reach for a value to index dict. Almost every string interview problem is one of those 3 in disguise. If you catch yourself writing a loop to search inside another loop, stop. You're one dictionary away from n. Day 14 done. The takeaway. String problems are counting problems wearing a costume. Subscribe for day 15.